Good afternoon, everyone. This is the ArcGIS Pro SDK for .NET session, enhancing the managed API using the Cartographic Information Model. The presenters are Wolf Kaiser and my name is Uma Harano. We are both product engineers in the ArcGIS Pro SDK team. Here is a session overview. I will start with defining the Cartographic Information Model, also known as a CIM, how to retrieve and access the CIM, and the transactional model it employs for updates. I will then switch to some practical applications of the CIM. We will learn what is a layer document. I'll show you how you can use the layer document and work with feature layers. Specifically, we will look into learning how to manipulate a layer's symbology, label classes, and display filters using the layer document and the CIM. Wolf will then take it over and dive into some advanced CIM concepts such as raster symbolization, and he will also discuss the layout document. The CIM stands for the Cartographic Information Model. It is a specification for persisting and transferring the state and structure of all Pro model entities. When we refer to model entities, we are talking about the map, the layer, the layout, reports, etc. Persisting and transferring refers to the contents and relationship. So what maps are in which project, what layers are in which map, how they symbolize, how they label, and their state. Their state refers to things such as what is visible in the map, in the TOC, is it editable, selectable, etc. The Pro model entities that I just spoke about, the maps, layers, etc., they provide a collection of convenient .NET properties and methods for most of the commonly used aspects. To access these models at a finer granular level, we have the CIM. There are a large number of properties on the model entities. We could have simply hoisted these properties onto the models directly and accessed them. Instead, we've used this technique called the progressive disclosure. We have the models as your high-level API, and when you need that finer granular access, you drill down into the CIM. In certain cases, there are no wrappers, so you have to use the CIM directly anyway. This is the case for renderers, symbols, and texts. The model entities, they have a CIM representation. The way you access the CIM representation is through the getDefinition setDefinition method pairs. It is a transactional patterns. You use the definition you get from CIM definition to make any changes that you want within the queued task context. And then you apply the changes back to the CIM using the setDefinition method as a single transaction. All the changes you make are propagated back to Pro through a series of internal sync events. All the panes and project panes in Pro get updated, and the CIM is stored within an internal database called a repository. The CIM entities themselves, they reside in the ArcGIS core CIM namespace. They all derive from the CIM object, and from the CIM object, they derive the capability to serialize and deserialize into XML and JSON format. The CIM entities are thread agnostic. They can be manipulated on any thread. However, the getDefinition and setDefinition method pairs must run within the queue task context. So in most cases, you will be manipulating the CIM on the queue task. When to use the CIM? We use the CIM primarily when the model properties are insufficient for the task at hand. If you examine the model properties and you don't see what you want, if you need a finer granular access, you go to the CIM. Additionally, if you want to make multiple changes and the model properties are available for you, you choose to use the CIM because you want to apply all your changes as a single transaction. So you use getDefinition to get the CIM, you make the changes and apply the changes as a single transaction using setDefinition. So in this case, you choose to use the CIM. Lastly, You have no corresponding model wrappers, you have no choice, and you have to use a SIM. Example, your renderers, labeling, symbology. So here in this slide is a basic pattern you would use to access the SIM. This is the transactional pattern. I'm first retrieving the hydrology layer from my map. Here I'm making the get definition call within the queue task, and then I make any changes that I need within this queue task lambda. In this particular code snippet, I'm not making any changes, and then I apply my changes back to the hydrology layer using the set definition method. Note here how I use the toXML instance method. Here I serialize the SIM representation into this string variable. This will allow me to analyze the SIM structure of the layer, which we will see in the demo coming up. Here is a slightly more complex example. I'm retrieving the hydrology layer, and then within the queue task, I'm using the get definition set definition pair. In this transaction, I'm making some changes. I'm changing the selection color of the layer to red. I'm setting the selection color property to this color red, as you can see here. And then I want to hide the legend in the TOC for this layer. So I'm setting the show legends property to false. Here I'm setting custom properties on the layer. This is something developers did very often with ArcObjects, and this is how you do it with Pro and the SIM now. So you first create a list of SIM string map, and then here I add a SIM string map object. It's a key and value pair. The key is my property, value is my value, and then I set the custom properties property on the SIM to this list. I convert it to an array using this method. And in the last step, I apply all these changes back to the SIM using the set definition method. The schematic on this slide shows you the full workflow of configuring a layer using the SIM. So on the top left here is a feature layer that I want to configure. So in this case, I want to change the layer's symbology. I first get the SIM definition from the feature layer using the get definition method. I cast the definition returned to a SIM feature layer so that I can access all the properties that I need to modify, such as the renderer, label class, query filters, etc. So in this case, I want to modify the renderer, and then I apply the changes back to the layer using the set definition method. Here on the lower right, you can see the modified layer in Pro. The layer has been rendered with a new symbology. There are several collection properties in the SIM. They are represented as arrays and not .NET lists. Given that they are arrays, they lack those nice semantics that lists have, such as add, update, remove, and so forth. So there are many times that you will want to update these collections in the SIM. Here in this slide, I'm going to show you how to update SIM's collection properties. This is the classes properties on the SIM. I'm converting it on the fly to a list using the toList link method. So now I have access to all the list .NET list semantics such as add. I'm using the add method over here, and I'm adding a new group to my collection. And then I update the classes property with my collection, and I modify it back to an array using the toArray link method. This is a pattern, this is a very convenient pattern that you can use to work with collection properties in the SIM. Before we go into the demo, I want to mention the SIM viewer. The SIM viewer is a freely available add-in. It is a diagnostic tool to examine the SIM definition. It leverages the XML nature of the SIM to view it in this pane in Pro. It is available in the Esri organization in GitHub, and the full path is given here on this slide. Okay. So in this demo, I want to show you how to work with the basic pattern of retrieving and accessing the SIM. So I have Pro open here, the simple project. This map is the detailed data set of hydrology in the US. Here on the CIM Demos tab, I have a series of buttons that I'm going to work through. Let's look at the first one that I've titled Basic Pattern. So my breakpoint in Visual Studio is set. This is the code that mimics what we saw on the slide for the basic pattern. I'm first retrieving the hydrology layer, and then within the queued task context, I retrieve the layer's SIM representation using the getDefinition method. Here you can make any changes. In this particular case, I'm not making any changes. And then I apply the changes back to the layer using the setDefinition method. Note here the use of the toXML instance method. I'm serializing the XML and storing it into this string variable. Let us look at the structure in the visualizer, in Visual Studio's text visualizer. Here you can see the sheer amount of properties that are available on the SIM. This is the reason why we did not expose all these properties directly onto the model. Okay, now let's hit continue and go back to Pro. And let's check out the next button, change map name. So I'm going to click this button, and in Pro, in this case here, I am getting the map, the active map. And then within the queue task, I'm getting the map's definition in this case. And I'm storing it in this variable. I'm using the getDefinition method. And then next, I want to make a simple change to the map. I'm setting the name property of the map to US hydrology map. Then I'm applying these changes back to the SIM using the setDefinition method. Now back in Pro, we can see this change. Here in this TOC, the map now has a new name, US hydrology map. Now let us look at the third button, change selection color. Again, I retrieve the hydrology layer. I get its definition within the queue task using the getDefinition method. Next, I make a couple of changes. I want to change the selection color on the layer, so I set the selection color to this color red. Next, I set the show legends property to false. This will hide the legend of this layer in the TOC. Here I'm adding a custom property to the layer. I first make a list of sim string map, and then I use the add method on the list to add a key value pair. And then here I'm setting the custom properties property to this list, and I'm converting it to an array on the fly. This is a convenient pattern that I showed you in the slides. Lastly, I apply all these changes back to the layer using the setDefinition method. Now let's look at these changes in Pro. First, here in the TOC, notice that the hydrology layer's legend is now hidden. Now I'm going to use this select tool to select a few features in the map, and notice that the selection color has now changed to red. I'm going to clear the selection, and this takes us to the end of the demo, the first demo, and I'm going to go back to our slides. Okay. Now let's switch focus to layer documents. The layer document is a Pro API class that provides the ability to work with an in-memory representation of a layer. The layer document class is available in the Pro API since version 2.4. It allows you to configure the layer properties prior to adding it to the map. This is an important enhancement to the Pro API. Without layer document, you had to first create the layer. This layer gets automatically added to the map, and then you could configure the layer using the SIM or the public API after it was already in the map. Let us look at the overall structure of the layer document. The layer document object contains the SIM layer document. You access the SIM layer document using the get SIM layer document method. The SIM layer document provides access to all aspects of the layer via the layer definitions property. Group layers will have multiple layer definitions, in this property, but this is not very common. So as I just mentioned in the previous slide, the SIM layer definition retrieved from the layer document is used to configure various aspects of the layers, such as your renderer, label classes, visibility, filters, etc. But the important point that I want to highlight here is the layer document's SIM layer definition is exactly the same as the layer's SIM definition that we looked at in the previous section. So this is the point that I want to make, illustrated in this code snippet here. Here is a pattern to use while working with layer documents. You construct the layer document first. There are three constructors available. You can use the layerx file stored on disk or an existing feature layer in your map. These are your typical options. You do have the ability to create a blank layer document that you have to configure from scratch, but this is rare. Then you access the SIM layer document's layer definitions property to make any changes you need. This is optional. In many cases, you might just use the layer document without any changes. Finally, you create a new layer using the SIM layer document. There is a special overload of the layer factory create layer method available for this. It uses a parameter object called the layer creation params. This consumes the SIM layer document. Then you use the layer creation params in the create layer method as seen in the code snippet at the bottom. So now the newly configured layer will get added to the map. Okay. So here is a code snippet of the pattern to use while working with the layer documents. I've highlighted the three main sequences over here. First, here I'm creating a new layer document using the constructor. In this case, I'm passing the layerx file. And then I'm retrieving the SIM layer document using the get SIM layer document method. Okay, so here is my step 2 where I access the layer definitions. And in this particular case, there is, it's not a group layer, so I access the first layer definition. I'm making a couple of changes. I'm setting the legend here to false, and I'm also accessing the render property on the layer definition and applying a new simple renderer. The third step, I create a new layer using the layer factories create layer overload. It takes the layer creation params that I've created over here, which consumes the SIM layer document. And this new layer, configured layer, will get added to the map. Next, I want to show you a couple of examples of the layer document pattern. In many cases, the symbology you need to render your data is stored in a layerx file on disk. You want to use the symbology from this layerx file. A popular geoprocessing tool for this task was the Apply Symbology from Layer tool. But now, with the availability of the layer document and the access it provides to the SIM, you can accomplish this task using the .NET API instead of the GP tool. So as you can see in the slide, you first create the layer document from the layerx file or an existing layer that has the symbology that you need. You access the SIM layer document and then its layer definitions from it. The layer definition contains the symbology you need to use. And then you use the symbology you unaltered, or you make any changes that you want. Next, you can either create a new layer from the SIM layer document, or you override the existing layer using the layer set render method. Okay, here is a code snippet for the apply symbology pattern. I'm first retrieving the hydrology layer from my active map, and then I store the hydrology layer's get definition using the get definition method. So over here, I am creating a layer document object. I'm using the constructor that consumed the layerx file. This is the layerx file that I have on disk that has the symbology that I want to use. I'm retrieving the SIM layer document using the get SIM layer document method. And then from the layer definitions of the SIM document, I retrieve the renderer and the label class file. So I store the renderer in this property renderer from label layer file. Notice that I access the first layer definition. Since this is not a group layer, I get the renderer property and I cast it to a class breaks renderer. That's the renderer in my layer X file that I want to use. Similarly, from the layer definitions, I get the label class file and I store it in my label class from layer file property. So now that I have the information that I need from my layer document, I'm going to use that in my hydrology layer. So I access the hydrology layer's SIM and I set the renderer property to the renderer from the layer file. And then I set the label classes property on the hydrology layer to the label class from layer file. Finally, I apply all these changes back to my hydrology layer using the set definition method. So to review what we discussed in this session today, we have seen two patterns of working with the SIM. The point I want to make here is that the work we do to manipulate and configure the SIM is the same. How we access and work in the SIM follows these two patterns shown on this slide. We started with option 1. We begin with an existing layer and access its SIM using the get definition method. We make changes to the SIM. Here in this code snippet, I'm modifying the filters. I'm modifying the filters, display filters for this feature layer. I add an array of display filters to the SIM display filter property over here. And then I'm applying all these changes back to the layer using the set definition method. Here is my option 2. I retrieve the SIM layer document from my hydrology layer document. And then very similar to this option over here, I access the display filters property on my layer definitions and I add my collection of display filters. Notice here that the work that we do to manipulate the SIM is very similar in these two options. Here in this option 2, the final step, I create a new layer using the layer creations object. I will show you these two workflows in the demo coming up. Okay. So this is the layer document demo that we will look at the workflows that we just discussed in the slides. So let's go back to the Pro project over here. Here is the same project that we were working on. So I'm going to continue working on the hydrology layer. So first, I'm going to turn the legend on for this layer. So let's start first with the basic layer document pattern. So I'm going to click this button, and here's a breakpoint in the code behind file. I retrieve the hydrology layer, and then within the context of the queue task, these are the 3 steps that I take while I work with layer documents. I first create my new layer document, and in this particular example, I'm going to create a layer document from the existing feature layer in the map, which is the hydrology layer. Next, I retrieve the SIM layer document using the get SIM layer document method. Next, I make some changes. So first, I access my layer definitions. I cast it to a feature layer. And now I have access to all the properties that I want to configure on the layer document. So I first set the show legends property to false. This will hide my legend in the TOC for this layer. And then I want to apply a new layer, new renderer. So I set the renderer property to this line symbol, which is a color red. Then the last step, I want to create a new layer from this layer document. So I first create my layer creation params object using the SIM layer document that we just configured. Next, I use the layer factory create layer method, and then I pass in the layer creation params. This will add the configured layer to map, which I'm going to see in Pro. I'm going to click continue. And here is my new layer. You can see that this, the color of the layer is now rendered with red. Okay, now I had turned off the symbology on this, turned off the legend on this layer, so I'm going to turn it back on. Okay. Okay. So a hydrology layer, as you can see here, has a lot of features, so it is difficult to see any patterns in it. I want to symbolize this data set based on the flow rate of the line segments. So I have a renderer on file that I want to use. So I'm going to use the apply symbology from layer file pattern that we just discussed. So let's click this button and hit the breakpoint in Visual Studio and step through this code. I first get this hydrology layer from the map that I want to symbolize. Then within the context of the queued task, I get the hydrology layers, get definition. I store it in this property over here. Next, here is the layer X file that I have on disk that has the symbology that I want to use. So I create a layer document using the constructor that consumes this layer X file. So the same as before, I get the sim layer document using the get sim layer document method. So this layer document has a class break renderer that I want to use to display my hydrology layer. So I get that from the layer documents, layer definitions property. I get the renderer property and notice that I cast it to a class break renderer. I store this in my renderer from layer file property. So similarly, there is a label class in the layer document that I want to use. I retrieve it from my layer definitions, label class property, and I store it in my label class from layer file property. So now that I have all the information I need from my layer document, I apply this back to my hydrology layer. So I access my hydrology layer's definition, and then I set the renderer property to my renderer from layer file. And then I do the same to my label classes. I set the label class property on the hydrology definition to the label class from layer file property. I turn on the labels to be visible, and then final step, I apply all these changes back to the layer using the set definition method. So now let us look at this in Pro, and you can see that the layer is now symbolized with this class breaks renderer with the flow rate. This gives us a little more information. But at this scale, there are still too many features drawing to extract any meaningful information from the map visually. So I'm going to use the SIM to add some display filters to control the feature density at different scales without impacting the symbology or the underlying features. So I'm going to click this Configure Layer with Display Filters button. And here is our breakpoint in Visual Studio. Again, the same pattern. I get my hydrology layer. Then within my queue task, I create a layer document object using the existing feature layer. And then here is a step where I access the contained sim layer document using the get sim layer document method. Okay, here I get the layer definitions property and I save it over here. Okay, now here I'm creating a list of sim display filters. I will be using this to set the hydrology layers display at different scales. So as you can see, each display filter item that I've added to this list has a query that specifies the flow rates at a scale range. Okay. So next, I'm setting the layer definitions display filters property to this collection of display filters that I've just made. I enable my display filters over here, and then the last step, I want to add this configured layer back to my map. So I create my layer creation params object. It consumes the layer definition, the sim layer definition that I just created, and then I call layer factories create layer method to add this configured layer back to Pro. Okay, so now let's hit continue to see this in Pro, and you can see that the hydrology layer is now drawn with the display filters enabled. The map shows only the rivers with the largest flow rates at a small scale. This was defined in our display filters. As I zoom in over here, you can see other line segments that appear. And then as I zoom in further, they also get labeled. So I want to show one final thing in this demo. Here is another map. I have the hydrology layer with a class break renderer. I'm going to configure this layer to use the display filters using the get definition, set definition pattern. So I'm going to click this pattern comparison button. Here is the breakpoint. Just like in the previous example, I get the hydrology layer. And then within the queue task, I access the layer sim representation using the get definition button method. And then just like I showed you before, here I create my array of sim display filters. I'm using the same queries and the scale ranges to display the filters. And then you notice here that I'm setting the display filters property on the sim definition of the hydrology layer to this collection of display filters. Then I enable the filters. This is the exact same sim manipulation code that I showed you in the previous example. So then the last step, I apply all these changes back to the layer using the set definition pattern. And let's look at this change in Pro. And you can see that the exact same display filters are enabled on this layer. And when you scroll in, zoom in, you can see that more features appear. So this concludes the first half of the session. On to Wolf now to learn more about the sim. Thank you.
Thanks, Uma. That was great. I'm going to delve into a couple of more practical examples on working with the sim. So when I work with the sim, the first question I always have is when I don't have a convenience.net property or method that I need for my features, can I use the sim to fill that gap? And first I need to look at the sim specification, which mainly covers maps, scenes, layouts, layers, symbols, and styles. So if it's another aspect of the API that I need help with, the sim will likely not help us with that. So next I have to find the sim's primary entry point, sim layer document, sim layout document, and then I can use the sim viewer, or I could leverage the sim serialization to XML in my code to look at the sim XML directly. Now, once I have that information, I can now drill down through the serialized sim and find the property that may be applicable to my needs. I then change that property, and as Uma showed us before, I now update the sim document with those changed properties using set definition or whatever other method there is to update the sim document. So to show you how this will work practically, I have two additional examples. One is the raster symbolization utilizing sim layer document, sim layer, sim raster layer, and sim styles. And then we look at how to customize a layout, mainly looking at the sim layout document. So how do I approach this? Well, first, there is a set of SDK resources that we can utilize to help us with this work. There's a little bit detective work that we have to do, so there's no straightforward approach because everything depends on your needs and the modifications you want to do to Pro. So you can see the SIM specification is one of the documents that we resource here. It's the very last HTTPS link you see on the screen. But also be aware of that we have plenty of snippets, samples, GeoNet entries, and API reference that helps you in your detective work trying to use the SIM. So let's take a look at the first example I want to show you, which is raster symbolization. What we want to do is we want to modify what's called the raster colorizer. You can see below the example, the out-of-box raster colorization that comes up when I load this raster, and it's really not what I want to use. This raster has an associated attribute table that allows me to use, for example, the land use attribute, which is a string, instead of the value. And it also has a count column that tells me how many pixels are of that particular data type. So what I want to get to is what you see on the right side on the screen, which is pretty much the legend being updated with a land use string, so I can read it. It's human readable. And I have a count right after that, which tells me the amount of data available for that specific type. And then you can see the colors are customized too, because I want to show my water and my wetlands in blue. I want to show my forest, my agriculture in green, and then build-ups and barren land in kind of gray. So these are the customers, the colors that I would like to show here. So working with the SIM, as I said before, requires usually a bit of detective work using the SDK resources. Usually what I start with is using the SIM viewer. So in this case here, what I did is I would select my raster layer in the TOC as you see on the right side, and then I would observe the layer definition using the SIM viewer, or I would go, if I have a piece of code ready, I would do in my code and do the toXML serialization to look at the XML in my code. Then I would use the SDK resources to find references to the SIM class that I have to work with for my feature. So let's take a look how that works. So again, here on the left side, I have my TOC. I selected land use. I now bring up the SIM viewer. It shows me my SIM raster layer document. And as I drill down and look at the information, I can see there is a colorizer property. I can also, if I already know that I have to change the colorizer property, I can do a Control F and search for colorizer, and it takes me right there. So you can see this colorizer property of the type SIM-raster unique value colorizer has groups. One of the groups is a SIM-raster unique value group. You can see it right here. This group contains classes, SIM-raster unique value type classes, and these classes themselves contain first the label that you see on the legend. So in this case, it would be a 1 for the first entry, and then a color to match that legend label and also the color on the map. So this is what I want to get to. This is what I want to modify. So what's next? So first of all, the XML element names correspond to the names of the SIM properties. So if we look at the element name here is colorizer, that would correspond to the property in my SIM class. So my SIM raster layer class contains a property that's called colorizer. Um, Then the type of that property is what you see under the typins, the type. So in this case, you can see my type of the colorizer property would be specifically a SIM raster unique value colorizer. And just as a side note here, the array properties in the SIM identify the name, and then each child element identifies the type. So for example, if I have the property groups, it's of the type array of sim raster unique value group, I can see that the first element within this groups property is a raster unique value group type. And the same applies to the classes property. When you look at the classes property here, which is of type array sim raster unique value class, you can see again the first element of this is a sim raster unique value class type. And that's going to be helpful when we do our code work to modify the arrays and the properties that we need for our functionality. Next slide. So my sim property is colorizer. So I know that. The .NET type is sim raster unique value. So I figured that out from just looking at the sim XML representation. So what do I do with this information? I consult the SDK resources, and now I learn how to access the raster colorizer. So mainly I find out that the raster layer, which you can see in this code snippet below, I assume that my first selected layer is a raster layer. I take that raster layer and I call the method getColorizer. So this retrieves the colorizer for the first layer that I have selected in my TOC. And it is, if I deal with this sim, of the type sim raster unique value colorizer. I can now modify that colorizer, and then on the layer I can call set colorizer, pass in that modified colorizer to change the color definition and the labels. I can also create a new colorizer using an attribute column. So the code snippet for that is below. I call the unique value colorizer definition and pass in the field name. So in my case, that would be land use. I now use that colorizer definition to create a colorizer. So the creation of the colorizer would give me all the different breakouts in my legend, my elements in my group, and then I can utilize this colorizer, can make more modifications if I need to. And again, I call the same set colorizer method to override the previous colorizer. So um, how exactly do I do this in code? So here you can see the map from sim XML presentation to a code snippet. We already located what we need to change. We want to change the label and the color. And you can see that little loop on the right side. I have my colorizer, which has a property called groups. Again, this is the name of the element, corresponds to that. The very first element, so I'm going to address that with the index of 0, has a property called classes. And now I go through all the classes that I have, and each class contains a label property, which is the string that appears on the legend, and it also contains a color. So this allows me to each one of the classes to override both color and label. Okay, now let's take a look at the first sample, the raster symbolization. We actually have that sample available as a community sample. If you want to look it up, you can download it and try it with the data itself yourself. So let's take a look first how we get to the code. You can see the rasters being displayed here. The legend is not what we want. I show the associated attribute table on the bottom. You can see I have my land use column that I want to use for my legend. And I also have the count that I want to display in addition to the land use string on my legend. And I want to customize all the colors as well. So let's take a look at the SIM first. I'll bring up the SIM viewer. I can look through the SIM raster layer myself to see if I can find anything that might be applicable to what I want to do. But since we already know that we're dealing with a colorizer change, I can do Control F for find colorizer and find my colorizer. So this is my colorizer property. It's of the type SIM raster unique value colorizer. Let me collapse these so we can see it better. And you can see we have a groups property, which is an array. And then we have in the first element, and this should be the only element we have here, because we only have one group, not multiple groups in our TOC. You can see in the first group, we have in the first SIM raster unique value group element, we have a property called classes. And when we look at the classes in here, you can see that we both have a label and a color attribute for each one of the classes. So the first one is label 1, which we can see over here with a green color. Let me collapse this a little bit here. So that's the first element. And then we have the second element, number 2. The label is 2, and the color is slightly different, and so on. So we have all the 7 elements in our group is listed right here. So now our trick is we need the code to modify this. So let's close this. And to step into the code, I initiate my add-in by selecting custom land use colors. And this is a snippet that we recognized from before, because what I do here is using the field name, in our case it's land use, I now create a new unique value colorizer definition, and I pass in this colorizer definition to create a whole new colorizer. So once this is done, I can now look through this colorizer. I should see my groups. There should be 1. If I look at the groups itself, I can look at the classes, and there's my seven different entries for the classes. So this is all nice and good, but I want to override the color and the label in each one of them. So let me just set a breakpoint at the first one, and then we can see what it looks like. So at the first one that I override, you can see the data here is brush transitional, and I have a count of 294. So what I did is I took the existing label that the system put in there for me by default, and I overrode it with the one that I want. So let's continue this. So now the whole group has been updated with new colors and labels. So here it is. I set the colorizer with the new colorizer in my raster layer, and I can continue. And now we can see the new color scheme that's being used, the dark green for the forest, the light green for agriculture. And we can also see that the count has been appended to the name of the land use type. So this is exactly what I wanted. So now we can go back to the slides. Okay, let's take a look at our second practical example, the layout customization. So what we want to do here is customize the layout map frame shape, and then we also want to customize the border symbol around the map frame. So in this case, I'm using a map where the map frame contains a 3D map view of the Kalalau Valley in Kauai. And I want to change the shape of that frame to represent the island of Kauai. And then I want to change the symbol for the border around that map frame to highlight that a little bit. So this is the layout that I started out with. I just used the standard tools to do this, but the customization I can't do out of box, so I gotta use the sim. So what I want to do is utilize the sim layout, uh, customize the layout map frame, and use a polygon feature as the map frame outline. So in this case, the island of Kauai, you can see the result on the side. So these are the two identical layouts, except the one on the right side has the island of Kauai as the map frame to show my 3D map. And then I have a little symbol boundary around that to kind of highlight the map just a tad. So this is the plan. Let's see how we're going to do it. So again, as before, we look at SDK resources, etc. And now we select the layout and then we observe the layout definition in the sim viewer. That's what I do, or in code. You know, if you have a piece of code handy, you could do the definition to XML to look at the XML representation of the sim. So now we have to hone in on the one class, the characteristic that we want to modify. So in this case, we want to modify the map frame because we want to change the frame for the map frame. So how do we do this? Well, we'll look for anything that's called map frame and we find it under the elements. So now we know that there is an array of elements. They are sim elements. And one of those is of a type sim map frame. That's the one that we are interested in. So again, you know, using the dot property hierarchy on the XML, we can utilize the code for this. So there's a snippet below. How do we get to the map frame? We get the sim layout from layout.getDefinition. And then we have a property called elements. We are only interested in elements that are type of sim map frame. And specifically, be only interested in the first and only one. So within the map frame now, we are looking for the border of that frame and whatever symbol it's using for its border. So take a closer look. We now look at the sim element with the type of sim map frame. So here it is, where we see, oh, there is a frame property and it's a type polygon. So we can try that and see if that's it. So that would be very nice. And then there is also a graphic frame that has a border symbol and specifically a line symbol. Hopefully that's the one that we can drape around that map frame and make look a little bit highlighted or different. So again, you know, this is a little bit detective work. This frame might not be the map frame, but it sure looks like it could be. So detective work here. So again, how do I get to the frame of the map frame? Easy. You know, I have my map frame from the code before. Now to replace that frame, I use a polygon builder. I create my polygon. And in my case, I can just use my feature class that has Kauai in it and just use that to create a polygon out of it. And then I can use that as a map frame. And then how do I change the border? So for that, I have to access the graphic frame property. As you can see here, graphic frame. It's of the type sim graphic frame. And then it contains a property called border symbol. And I change the symbol for that to a line symbol with my features that I would like to have. Okay, now let's take a look at the sample, the layout customization sample in code. And I already have this running in my debugger. Let's bring it up. So you can see my my layout is already up. It's a standard layout that I designed with a rectangular area for my map frame, which contains my 3D map. And what I do first, as always, I bring up the sim viewer. Let me bring up the sim viewer here with my sim layout. Um, as we drill down, we can see an array of elements. Within the array of elements, I have sim element data types. One of those sim element properties that I have here is a sim map frame. So the sim map frame is what I want to focus on to change the frame for my map frame, which I strongly suspect is this property. And then furthermore, I want to modify the border symbol that I use around that map frame, which I strongly suspect is this border symbol here right now under my graphic frame property. So this is what I already showed you this in the slides earlier. So this is my detective work to kind of find out what do I need to do in code to get my functionality to customize my map frame. So the way we do this is I can initiate my add-in through this change map frame button, and we hit our first breakpoint. This is the snippet I wanted to show you. This is to retrieve the first map frame, and I guess in my code it's the only map frame that I have in my layout. And I go through the elements property, which is an array of sim elements, and one of them is specifically the type of sim map frame. That's the one I'm interested in. So as we step over, you can see this is resulted in a proper sim map frame element. So I then retrieve my frame polygon from my geodatabase. I have one I called Kauai border buffer that has the outline of the island. I retrieve that, and then I call a function to actually create my map frame polygon. Within this function, I do a little buffering. I retrieve the features. I union the polygon, which I didn't have to because this is just a single feature. Uh, it's not a multi-part polygon. Then I reproject it using plat carré. That is necessary to make it flatten it out a little bit, make it look a little bit less distorted because I'm using different projections for that geometry. I shrink it, I move it into the proper place. I generalize it a little bit to make the edges less sharp. And then once I have that polygon, I go back to my calling function, and I now use that polygon that I just built from the island of Kauai, and I override the current frame, which is the rectangle area that I have around my map frame. And then furthermore, in the next call here, I construct a line symbol. The color that I use here is kind of a light cyan blue kind of color. I make it uh, three pixels or elements thick, and I take that line, and that is the line I want to use as my border symbol around the map frame. And then finally, I take the definition from which I updated just the map frame part, and I update the layout with that new definition. Let's continue. So now you can see the shape of the island of Kauai right here on my layout. I have my border around it with that light cyan color. And I have my expected result. Looks pretty unique. Looks like a bunch of pictures, but it's actually a map. So a very, very powerful way to use the sim to do some extreme customization. Okay, and now let's go back to the slides. And we reached the end. If you're interested in any of the session materials, they're going to be available here for download. You can use the QR code or you can use the link that we provide to get the session materials. And thank you again for joining us, and see you on the GeoNet. Goodbye.